Hey, nice to meet everyone. Hey, Chang. Hey, Kourosh.
Hey, morning.
Hey, yeah, let's do a quick intro then. So my name is Sven. I'm the team lead of the reinforcement learning team at AnyScale. We're the company behind the Ray open source project, and my team is responsible for developing and maintaining RLlib. We're about 5 or 6 full-time RL engineers. Keeps changing as we grow and resize. And yeah, we'll have these office hours every 2 weeks. Thanks, Christy, for organizing these. I think so far it's been going really well. We're seeing different people every time we do this. Some regulars, some new people. So this is really interesting. And I think what this is about is for you to ask questions, to get unblocked with your issues, and for us to give some top-level overview of or high-level overview of what we're working on, what we're planning to do in the next couple of quarters or next year. And of course, answer your questions. I think what's interesting once you introduce yourself is what are you working on, why are you using RLlib, and maybe one sentence why you like RLlib or why you don't, or what could be better. We always welcome, very constructive criticism. Of course, this is super important. Okay, maybe Kourosh, go ahead, and then the others, Matthias and Chang.
Yeah, I'm pretty much like Sven, part of our lead team on AnyScale. I joined about 2 months ago. Very curious to what pain points people are going through when using it, so we can make a better product for everyone.
Matthias?
Hi, I'm Matthias. I'm a postdoc at Harvard working on multi-agent RL, mostly methodology. We're using RLlib. I guess it's the main multi-agent capable RL library out there. And it's fantastic. Maybe the one pain point is that it can do so many things that it's a bit hard to get to know all parts of it, and sometimes the documentation is lagging a little bit behind. But I think that's just the way it is if you're able to do so many things.
Yeah, it's a design problem, I guess. It comes with it's the ups and downs of trying to do everything. Yeah, absolutely. Yeah. Thanks. Yeah, cool. Chang, you want to go next?
Thanks, Sven. Really nice to meet the RLlib team. I am a PhD student at the University of Sydney. I'm studying RLlib for my reinforcement learning framework, and I'm currently having trouble autoscaling it on the AWS cluster. So yeah, really looking forward to this tutorial. Thanks so much.
Okay.
Yeah, hi. Nice meeting you all again. Yeah, I'm Simon. Some people know me already. I'm also a contributor to Ray, especially RLlib, which I use. I'm coming from the field of math and economics, like did game theory and machine learning, and from this somehow also made this way towards reinforcement learning, where I think like all the older guys actually make such a way, like there was never a straight way before. Yes, I'm applying reinforcement learning, and that's also where I'm using RLlib and want to use it even more with my own business, newway.ai. And yeah, always like to be here and discuss more about RLlib and know where people have problems. Yeah, thanks.
Thanks, Sam. Yeah, Sam is a regular. It's good to have you. Yeah, so I was in the other chat with Matthias and the other Zoom link. So he's working on multi-agent problems, and he had a question on how you can. He wanted to better understand how the multi-agent setup works in RLlib, and how you could use different algorithms kind of within the same algorithm, so that the different agents in the multi-agent setup exist in the same environment, and how would this work? So I was going to explain to him. I'm assuming you see my screen, everyone, right now. So I was telling him right now. So I think Manny the other day, who's also like a regular in this group, Manny Vindiola, he answered his question, and he's tried to like help him a little bit. And he said you can use different policies. You can use the same. You pick one algorithm. And then in the algorithm, in your multi-agent config dictionary, you kind of set up different policies for your different agents that walk around in your environment. And then I explained to him that only works then, of course, if the policies are kind of matching the type of algorithm that you choose. So if you, for example, you would probably get into trouble if you chose a PPO policy and a DQN policy with their losses, with the respective losses, and you would use both of them inside a DQN algorithm, which has a buffer, and then the PPO would probably complain because it's off policy and so on. So I was explaining to him that you could also write your own algorithm, and we have done a lot of work to make this easier. And I was showing him showing Matthias the new kind of setup. You have RLlib now, and there's a new algorithms folder, and all the what used to be called trainers are now in this algorithms folder. And each of these algorithms has its own folder. So for example, simple Q is no longer part of DQN, but it has its own top-level folder, and you can, for example, go here. And if you take a look at simple Q, there's always like one main file, which is called algorithm.py. So in this example, simpleq.py. And every algorithm now has a training step method. So if you scroll down a little bit, you see the simple Q algorithm, which subclass from the algorithm class. Before this was called trainer. Now it's called algorithm. And then you have some config stuff here, and further down you have basically the heart of the algorithm. It's the training step method, and that's the method that keeps being called repeatedly as you iterate through your training process, as you call .train, right? So you can, and then each time you call .train, this training step method gets called one or more times. Depending on how long you set your iterations to be, you can set a minimum time. You can say each iteration should take 10 seconds or 100 seconds, and then it will call it several times, this method, until it gathered or it accumulated this time. And you can see here, this is it's actually quite simple. Like, you can kind of read through the code here. The basic idea is that you have a utility function that you call. You can use these as well for your own algorithms, or you can also look inside what's happening here. Here in this function call, we parallelly stepped or we parallelly ping all the rollout workers that we have, and those are the workers that step through the environment to collect samples. So we parallelly ping them using Ray, and then we collect all these samples in parallel and kind of either concatenate them, or here in this case they come back as a list. So one batch for each parallel rollout worker. Next, we store them in a buffer. This is what DQN does. Then we sample from the buffer. What else do we do? This gives us a train batch. So we put all the samples the new samples into the buffer. Then we uniformly sample from the buffer, and we use that uniform sample to train one step. There are two different ways here: multi-GPU and train one, and the simple one. And then what else do we do? We update priorities in the buffer in case we have a prioritized replay buffer. And then we synchronize the updated weights back to the rotor workers, so that the workers that step through the environment have the newest version of the weights. So basically, you have a local version of your worker, which holds all the models and neural networks. It's kind of like a parameter server, and that's where the update happens. And then after the update, you sync all the weights back to the workers, so that in the next step they have the newest weights. And then you return some results dictionary, and you can basically now subclass either from simple Q or from algorithm directly, or from any of the other algorithms, and override this method if you want. You can do some stuff here with your worker set. Feel free to browse around in different algorithms. If you say I want to have some derivative of, for example, of PPO, feel free to go to PPO and check that. The training step method of that algorithm, and you can see that they're all pretty simple. Every training step usually fits on like one page. Roughly, what they all do is they sample, store the samples somewhere, or funnel them through some queue, perform an update, and then synchronize the weights, and that's it. Really, 90% of our algorithms. Yeah.
In a multi-agent setting, if it just pass in different kinds of policy classes into the policy spec of each agent, I'm still passing in one trainer object in the old version, at least, or one algorithm, I guess, in the new version of doing things. So it's going to be using the training step from that trainer that I pass in, correct?
Exactly, correct. So whatever algorithm you choose, that will be the training step. So now what's happening? This is a great question. So now let me explain to you where the policies come in. let's go back to the simple queue because that's the one we know now. So what's happening here? So we have in this call here, let me actually step in here. Again, this is a utility function. You can take a look. It's also quite simple. It basically just says while some minimum time is not reached, ping all the workers in the worker set, the remote workers, and say a dot sample. Yeah, so basically, this is the array remote call here. And then the sample method of these workers will do a couple of steps in the environment. And these steps will happen with the different policies that you specified. So let's say you have a multi-agent environment where you have, let's keep it very simple. You have two agents, agent A, agent B, and agent A maps to policy A and agent B maps to policy B. Yeah. And let's assume that maybe there are different policy classes. Maybe one is the PPO policy and one is a modified version of the PPO. Maybe it's something that you wrote because you want to compare the loss functions or something. So then these two different policies are used in the sampling process as for calculating actions, for basically computing using the networks and computing the actions. And the samples are gathered as what we call a multi-agent batch, which is a batch of the two agents that walk around. They have different observations, they have different rewards and different actions. And this multi-agent batch is then returned here in this from this utility function. Let's go back to a simple queue. So this into this list here. So this list here will now be a list of multi-agent batches. Yeah, and each multi-agent batch comes from one of the roller workers, and each multi-agent batch contains both the agent's observations. And then what we do in this train, and you can use the same buffers here. The buffers also store the multi-agent stuff. It all works pretty much the same. And then the next difference is here in this train one step or multi-GPU train one step. Let's take the simple one. Let's go to train one step. And what you can see here is that eventually we call the local workers learn on batch method, which contains all the different policies as a parameter server. So it has basically the ground truth versions of all these policies. And then we call this one's learn on batch method.
And then with different policy
and that
classes,
one looks
different learn on batch, but
correct. And that one loops through all the.
Be correct, but I might be constructing the batches in the wrong way if I mix DQN and PPO, for instance.
Yes, correct. Yeah. Yes. Yeah, because for PPO you need to. Well, the post-processing, if you want to calculate, for example, advantages for PPO, that would be taken care of by the policy itself as well. So a policy maybe also to explain.
I might be creating a batch that's like a prioritized experience replay sample from. It might be an off-policy batch even at that point, right?
If you use simple queue, yeah, because then you go through the buffer and then you sample from the buffer, and at that moment you get some old samples from some older policy or older versions.
Which PPO I wouldn't want, and that's why that might not work the right way. Okay.
Yeah. So it's important to understand that there's a policy which computes actions, and it does some post-processing of the trajectory, for example, calculating advantages for PPO, and that's what we call the policy. And then there's the algorithm, which basically tells what should happen in which order. So sample using the policies, store the buffer, sample from buffer, and update. And then here in the update, you can see the multi-agent case. Yeah.
Sorry. Oh, that's also why it's a little bit non-trivial to mix and match random algorithms, because A3C collects experiences differently than DQN and so on.
Correct. Yeah, correct.
Yeah. Okay. Okay, makes sense.
Yeah, and sometimes their losses may not even work. Like if you have, if you trying to teach PPO or train PPO on outdated data on old data, it will not learn properly.
Vice versa. If I pass in PPO as the trainer, then the DQN policy would only ever get most recent samples and learn very efficiently.
Correct, because there's no buffer. Yes, correct. Yeah, that's right. Yeah.
I'm actually a bit curious, Matthias. Can you maybe for 2 minutes explain your use case exactly? Why would you need to combine, let's say, two distinctly different algorithms into a multi-agent scenario?
So this one so far is really only a question of curiosity, because I want to understand how the RLlib architecture works here.
Okay.
But we do have some problems we construct where different agents are solving very different problems. So it would be interesting to us to see if, let's say, PPO for one agent and DQN for the other works better than PPO for both or DQN for both.
Got it. Got it. So maybe like the other example that Sven we have that kind of alternately calls DQN or PPO train method. You have something similar to that in the examples, right? Like
I've seen that. That's where I started from, and with that one, it's sort of you create two completely separate training processes, basically including separate environments, if I understand.
Oh yeah, got it.
And you synchronize weights back and forth, which might work for most of our use cases, but I'm not 100% sure to complicate things.
So in one of the trainers, you basically specify that the DQN policy is not for you to train; it's just used for sampling.
Yeah.
In the DQN, you say, "Hey, PPO is not for you to train. Let's just use that for sampling."
Yeah.
And then, alternatively, you sync up the weights. So I think that captures the use case that you are targeting.
My meta question is, how can I, in a multi-agent setting, have complete control over how experiences are generated and how they go to different agents? With all of these it's the trainer that creates the environments and has complete control over it, but I really want to be in charge of the environment, so to speak, and
I see. Yeah. So you have
experiences with different agents.
Got it.
So there are different things you could do, Matthias. So one is you could use the observation function in the multi-agent. Let me go back to the algorithm config. As you set up your multi-agent, there is a observation function, and you can define a function that takes in all the agents' observations and then outputs basically a new observation stick for the different agents. So you could mix. Maybe agent 1 wants to not only see its own observation that comes from the environment, but also see agent 3.
That's an interesting one.
You could combine this on the very lowest level of the observation. So there's no neural network yet. It's just pure observation magic. Yeah, you could use that. So that's a tool, for example.
But it's kind of a function calls around the return from environment.step, basically.
Exactly, it's kind of a wrapper around the environment. Yeah, that's
okay.
Reshuffle whatever agents wants from the other agents. Yeah. That's one thing. Also, what may be useful for you is to take a look at our examples folder. There's a centralized critic example. And that one also shows you some stuff of how you can use post-processing in your policy. So you could specify your own custom policy and then override the post-process trajectory method. And in there, you also receive the other agent's observations. So you can, for example, maybe mess with the rewards, or like combine the observations, or add the other agent's actions to your observations, or to your sample batch in general, so that the model of the other agent then sees that information. So you can do that as well. So there's 2 examples here. They work slightly in different ways. I have to say they're not truly centralized, because in the end the critic is still separate for the different agents, but they're basically centralized in the sense that they do the
critic gets all the information.
They receive the same data. They receive the same post-processed data.
Yeah, interesting.
We still train it separately, which is kind of a problem that we're trying to solve by what I mentioned before. We're trying to change some of the APIs to make it easier to construct these really difficult and complex cases where you share.
One thing that I've looked into last night a little bit that goes into a slightly different direction, but gives me more of what I'm looking for, is external environment. Basically, it's not the trainer that's in control of the main loop, it's the environment. And in the environment main loop, I can decide, okay, now I do stuff in the environment, and now I pull one of the policies for actions. I played around with that a little bit. One quick question I had about that basically subclasses directly from base env Do I then need to worry myself about sampling from multiple in parallel, or does it still happen with multiple rollout workers?
The external env setup is basically a setup or a design for having a one or more environment clients. So let's say you have a super heavy simulator that simulates some some process, and you have and it has to run outside of your I don't know, outside of Python, outside of your regular setup. You could run these on different machines, and they all use the RLlib policy client, which there's these examples here that show you how to do this. So all these environments, these on the client side, and now you have, this is your parallelism basically. They could talk to the same RLlib policy server, which you can set up on another, maybe on a GPU machine, as in a centralized way. It opens a couple of ports. That server may have several workers if you want to have different incoming connections on different ports. And then the different clients, let's say you maybe have 100 clients, they can all connect to one of these ports. And that's how you get parallelism on the server side, by having several world workers and several open ports, and they all collect data and they batch it together, and then they do the same that I showed before in the it's the same algorithms, same training step methods. They just basically wait for data.
But don't need to use policy client and policy server with external env, right?
Yeah, you don't have to. Let's see. Yeah, you could simply write your own external environment subclass. And then in the end, so in the end in RLlib, as soon as you use some of the algorithms, they will always convert. Everything always gets converted into a base env. Yeah. So
yeah.
But yeah, you could in your config. Actually, I'm not sure. I never did this. I think I never tried providing a custom external env. You would have to.
I tried that last night. That does seem to work.
Okay. It does seem okay.
The one thing I noticed is that with the standard environment, you subclass usually from somewhere from vector env. So I think that RLlib would parallelize even within the same rollout worker you could tell it to. But I don't need to worry about that if I just give it multiple rollout workers, it will still parallelize even with external env, right?
Yeah, that's a good question. The vectorized, so we have external env, we have external multi. I'm not sure what happens in the vectorized case. I think that's a good question.
But basically, even without vector env, if there's multiple rollout workers, it will run multiple.
Yeah, then you have the parallelism there. Yeah, exactly. Even if you don't have vectorization.
That's fine.
Actually, that's something I have to look up, whether we support external envs even as a vectorized sequential stack, kind of. Like, I'm not sure actually. I can't. It may not be possible. It's maybe something that we say because it's external anyways.
I think the paradigm is a bit weird, right? Like someone else is blocking you. How do you say it's parallelized? Like
returns.
And then my second question is because
sorry to interrupt, Matthias. So here it's not possible.
Subclass directed from sorry
to interrupt. So here's the answer. So if num n is not equal to 1, then we say you cannot support vectorization, basically.
If I subclass from external env, the external env class itself is not a base env. I think it subclasses from threading.thread or something.
Correct.
And it's to me that RLlib internally then wraps this around something that looks like a base env.
It's what happens here exactly. So everything in RLlib, whatever you do, whether you supply gym env or a multi-agent env or a vectorized env or an external multi-agent env, everything always automatically gets converted in the end to a base env. And RLlib under the hood in the sampling process uses that base env API.
So if I wanted to have an external env and put a wrapper around it, I would need to call something like toBaseEnv on the external env and pass that into a wrapper. Some architecture like that could work, correct?
You could just provide your subclass of external env. RLlib would know, oh, it's an external env, so let me call the toBaseEnv.
Yeah, but my environment
you could override it.
So if I put something like DeepMind observation wrappers directly around the base env, that wouldn't work because that observation wrapper doesn't know what to do with the thread. But if I convert to base env first, or do something similar with a gym env, that could work, right?
Yeah, with the gym env, yeah, I'm not sure about DeepMind.
I mean, it's not specifically about the DeepMind wrappers, but
yeah, with the gym env, you can definitely slap a wrap around it and then provide that. That works, of course. Yeah.
Okay.
You can write. Yeah. That's the recommended way of doing things. If you want to, basically hack your env. We recommend to use gym wrappers, wrap it again for the reward, for the observation, and then hand that to RLlib.
Yeah. Okay. One thing I've also been trying to do in one of my settings is have multiple agents and have from the same sequence of observations, actions, have different episode segmentations for different agents. So my environment generates 20 steps. For agent 1, that's one single 20-step episode. For agent 2, it should be 2 episodes of 10 steps each. Doesn't directly work if I just set done for the agent true in the middle of the episode and then unset it. Then there is a complaint from the sample collector that it breaks down somewhere in the sample collector. Many on Discuss had a really interesting workaround where basically I make 2 copies of agent 2, so I have 3 agents in the environment, and agent 2A and agent 2B I map to the same policy in the policy map function. And I think that does the trick, that should do what I wanted to do. It's a little bit tedious though, because I now have to keep track of 2 or potentially very, very many copies of agent 2 in the environment. I also have to know in advance how many the maximum is ever going to be, because RLlib wants to have this set of agents, agent IDs. Is there an easier way to do what I want to do?
That sounds pretty hackish, pretty genius. But then, I agree. It would move the problem into the environment, then it becomes ugly there, maybe. As hopefully I understood it correctly, but you can also use a callback.
Okay.
Yeah, so if you go to the examples folder, there's a custom callbacks example.
That would be on something
like then you don't have to write a subclass. Yeah, and then you can
So on post-process trajectory, I look for whenever in the info dictionary my special key is set to true, I insert the done into the trajectory.
Correct. You basically in this method here, if you take the callbacks, just use the default callbacks, override the post-process trajectory methods. In there, you get the post-process batch. Yeah, so this is your multi-agent batch arriving right now for this particular policy. Here you can say you can measure the length. You can say after 20 or after 10, I'm going to insert a done, and then do something with that, and then that will eventually be forwarded to the loss function. Yeah.
Okay.
So that's, I think, should work. Let's take PPO, and then PPO would use the done flag to properly calculate the advantages or the GAE, whatever. And again, you can tinker here in this. You can tinker with the rewards. You can add more done flags or change the actions or whatever you want to do. This is all pre-loss calculation, so this should work. Yeah.
Okay. Awesome.
Cool.
Perfect. Thank you.
Yeah. Sure. Of course. Great questions. Really deep. It is nice. So should we, Chang? Should we talk about your problem with the auto scaling?
Yeah. Many thanks.
Sure.
Would you mind if I share my screen?
Of course. Sorry. Let me. I stopped sharing. So go ahead.
Okay. Thanks a lot. I actually posted my issue on GitHub, and I just sent the link in the comment. So my use case is much simpler. So as you can see here, the GPU.yaml file is just the one I copy and paste from the official GitHub repo for the AWS cluster. And for my cluster, I used the RLML image with NVIDIA Docker, and for both both head and worker. For both head and worker, I use the same image. And also for the instance type, I'm just for test, I'm using P2 extra large here. Each instance carries 2 GPUs and 4 CPUs. And this is basically all my YAML file. And for the RLlib, this one is copied from the official repos DDPO configuration. And in this configuration, the number of workers is 4, and per GPU per worker is 1. And so the way I'm executing those YAML files is like re-up GPU.yaml and synchronize my my RLlib YAML files to the server. And then this step is I'm really confused. Should I just execute RLlib on the head node? Am I doing this correct?
Can you so your header in your YAML file is so the name of your cluster is gpu.yaml?
Yeah, correct. The name is gpu.yaml.
Got it.
Yeah, and this one is just for the DDPPO algorithm.
And I haven't worked with the open source in a very long time. I think this is the way to do this, right? Ray exec. What happens when you do this? When you run the line 230, what happens to the exec line?
And the problem here is it does not scale. So above this line is the result after executing the execution line. Yeah.
Sorry, Kourosh, go ahead.
So if it's impending, you don't have enough resources on that cluster.
Yeah, so basically, so you're using DDPPO, you're using num GPUs per worker, and you have 4 workers, so you need 4 GPUs, right? And I think your P3.
But there are only 2 GPUs on that cluster.
Yeah, or even just one. Hold on. How many? You have 2. What is your min number of workers and max in the cluster config? 1 and 2 and 10 or something I saw?
It is 1 and 20.
1 and 20. Okay. So you start with 1 and then it doesn't scale. It doesn't bring up the next machine to reach the 4 GPUs, right? So each machine has how many? What is your machine time? P2.
P2 X large.
So a P2X large has 1 GPU and 4 CPUs, and that's exactly what it shows in your pending, where it says pending, and you look like 3 lines above that. It says resources requested 0 of 4 CPUs and 0 of 1 GPU. So that's you basically brought up a single machine, a single P2.
But if it's a single P2, you only have 1 GPU there. It says 0 out of 1. It's not 2 GPUs.
No, but they only have 1. So they only have 1 GPU.
Yeah.
The problem is that it doesn't seem to autoscale, and the question is why, right?
But the quota is there, right? You have enough quota for the resources. That was sometimes a problem I had.
Yeah, I have enough quota for that.
Right.
Okay, let's see. And then the demands, it says 1 CPU for the driver. That's okay. And then 4 pack. That's the 4 workers. Each one needs 1 CPU and 1 GPU. That sounds all good. Placement groups, okay. And then the autoscaler. So what does the autoscaler do? Pending. Yeah, what we sometimes tell people is to try like a larger node from the go already. So instead of P2X large, P2 8X large or something that has enough. So you have enough GPUs right away. But it is. I acknowledge it is a problem. It should properly autoscale. I mean, it may take a while, it may take a minute or so, but at some point it should bring up all these 4. It should bring up 4 P2X large machines because you need 4 GPUs. Right?
Yeah.
And that's apparently not happening, and that's that's not good.
So just a couple of like debugging question. Have you tried, I don't know, bringing your resource request down to fit like in a single instance, or try a larger instance? Does that work?
I actually tried the non-GPU version. It also does not work.
Can you try the non-GPU version with only 3 workers, so that then you have 4 CPUs, right?
Yeah.
3 for the workers and 1 for the driver.
I believe should be this YAML file. Just let me double check. And,
yeah, just get it to run with some setting, and then we can take it from there.
Yeah.
I do think there's a problem though, Kourosh, in
Yeah.
the autoscale and RLlib. Don't know. I'm not.
Maybe this one.
We've seen problems like this before.
Should be this one, right?
Yeah, this is your config. So we just try exactly. Just set num workers to 3, let's say.
Okay.
Num GPU 0, num GPUs per worker also 0. Sorry, that looks a little different. That's not your DDPPO file.
Yeah, that's PPO. So DDPPO has to specify at least 1 GPU.
Yeah, normally, yeah.
Yeah.
I think you can also run it without GPUs actually, but.
This should be okay. Let's just roll it.
Yeah. Let's try that.
Let me just try this one. Okay. I'll terminate this.
Simon, you had also sometimes problems with bringing up clusters, right? Or with auto-scaling. I remember you had, or was it just a single node thing that didn't work?
Yeah, it was very similar to this one. And for me, it was like one issue was actually due to the quota. So there wasn't more GPU available for me. So that kept pending. And then I remember there was something with the accelerators. I also had to like somehow increase the accelerators, or at least say that in the YAML file, such that it started to run. But I tried to like find that problem again.
Yeah. In this case, I think everything works.
Yeah, that's okay. So that minimal example works. Okay, that's just without GPUs.
Yeah, but
got it. So this one is running. Okay, makes sense.
Yeah, but the auto scaling also does not work.
Yeah,
but you can also see, right, like the other ones are pending. It's not requesting
because you only have 4 CPUs on that machine.
Yeah, but there are 4 experiments, right?
I know, but each one takes 3 workers, so this is.
Yes, but if the auto scaler would have worked, they should have run in parallel, right?
Oh yeah, okay, yeah, true. Right. Yeah. The autoscale look like there's nothing wrong, right? It's just
the demand is 3 pending placement groups.
Right, but then it doesn't really act on it, or it doesn't say why it's not doing anything.
Yeah, and actually, if I change this one, if I change the minimum workers, like to 3 or something, the RLlib cluster can actually fetch up like 3 workers, but still the RLlib is not able to dispatch those tasks to those workers.
Okay.
Yeah, so it will still be pending.
Weird.
Yeah, I would imagine if you set min workers higher, then it wouldn't have to auto scale. It would just start right away with a large number of nodes, and then it would be okay.
Yeah. It should be this way, but in fact, it does not work. I don't know why. It seems only take whatever it has on the head node.
So can you attach your issue with this exact like config file, the PPO one and the YAML cluster, the YAML for the cluster? So we can look at it offline.
Yep. In my issue, I posted those files here.
Oh, okay.
Yeah.
So that's your GPU YAML, and then the RLlib test YAML. Is that the DDPO one?
PPO one, yeah.
Yeah. Okay. Okay, but it didn't work even for the tuned example like Atari PPO, right? where you have 4 experiments, but all of them require like only four CPUs. You don't run the experiments in parallel. It just runs one at a time.
Yeah, yeah.
Okay, so it's not really GPU issue at all. It's just like a placement.
Autoscaling, yeah.
Yeah, just auto-scaling issue, I guess.
Okay, we can take a look at it.
Okay, thanks so much. And also another quick question. How do I, if I'm using the Ray cluster and with Docker image, I didn't see in the YAML file where I can expose my port. So my goal here is to use the Ray dashboard. But in this case, since I did not forward the port from the Docker to the instance, the dashboard is actually not working. Yeah, and if now so the way I'm connected to this SSH is through the port forwarding. I specified the -l argument to forward this port to my local computer. But if I visit the 8265, there's nothing comes up. And instead, if I do not use Docker image here, if I simply remove this section, and everything will works. Yeah, I guess the issue is that the Docker does not forward its port.
Yeah, it could be, yeah, exactly. It could be a port inside the Docker or something like that. Did you ask this question on the
yeah. Let me just quick check the issue number.
Maybe we can escalate this, yeah.
Should be this one.
Alex is on, okay.
Yeah, should be this one.
Yeah, can you put it in the chat here? I can ping it.
Yeah. Thank you guys so much. That's all my questions.
I will ping someone on that issue. Take another look again. Yeah, thanks everyone for your time, for your sharing the problems with us. And,
thank you.
Yeah, of course. Again, this is every 2 weeks. Feel free to show up regularly and participate. Yeah, good to see everyone.
Yeah.
Have a nice rest of your day. Okay, take care. Bye.
Thank you. Bye.
Bye.